Now we're going to introduce a new type in F# called enumerations or enums. And you might be familiar with these if you've used other languages like C#, for example. The way we would define one of these is with the type declaration, and then we would give this some name. We can call the type that we're defining color, for example, and then we would define simply the various types of colors that we can have. Let's say we have red as one color, and we would give that a number of 0. Let me explain that in more detail in just a second. Then we would define the next one called green, and we give that a number of 1, let's say, like so, and finally we might do blue. Alright, like that. And you can see right away that the definition here is quite similar to the definition of a discriminated union, if you remember that. So again, we have a type declaration, but what differs is how we define the elements that constitute this enumeration in this case. You can see that we have numbers on the right side here, and when we talked about discriminated unions, we used the off keyword rather than the equal sign, and then we simply defined a number of parameters, and you would then initialize the subcomponents of the discriminated union. So a bit different in terms of the body of actually how these types are defined. And the way these enumerations work in F# is that this number here corresponds always to one value of your enumeration. So you can match between numbers and the types of this as well, which makes it quite flexible across languages. So let's say you're using a .NET application or a suite of different programs, so you're trying to integrate F# with C#, for example, and enumeration would be quite good because you can actually use that in both languages and have sort of a seamless transition between the two. It's harder for discriminated unions, which are not defined in languages like C# and are therefore more restrictive to the F# language. So let's see how we would use an enumeration in practice if we define some code. So the way we would reference this is we could define some variable in this case, so let's call it color1, and then we can reference one of these colors that we now defined in our enumeration type. So we would use the word color from the enumeration, and then we have some values that we could select from here. And you can see also in the highlighting that we get the corresponding integer value here of 2 for the blue one, and if we go down to the green one, you can see that the corresponding integer value is 1 and so forth. So let's just do red for this example. So this is how you would instantiate one of these particular colors and then use that in your program. You can also use an integer and convert that in turn to one of these enumeration types. So if we do that as an example, what we would have is some number variable, so my number, and we will just set that to be 1 in this case. That should of course correspond to one of the numbers that you've defined in your enumeration to begin with. The way you would convert this then to an actual enumeration is if we make a color here, so my col, that would be enum. So you need to specify that you're converting this to an enum. Then you need to specify the type within these brackets here, and in this case that would be color, like so. And after that, you would then put in parentheses the actual value, and in this case we would use my num. So what we're saying here is we're going to convert my num, which is 1, to one of the colors that we have in our enumeration here. And you can then do various kinds of manipulations with these variables, of course. So if we want to print whatever color we have, for example, we could do that using a match statement. So we could define a string variable, my string, like this, and we would use the match keyword, and we've done a video on the match statements before, so you can watch that if you haven't seen it. And then you can match my color in this case with the different enumeration types. So we would then define a match statement like this, and then we could put in the various different colors that we have at our disposal and try to match them essentially. So we would define color.red, and if we have this, then the string that we would define is red, like so. And we could do this for the other colors as well. So color.green, and then that would correspond to the string green. And we would do the same thing for color.blue. Now, once we've done this, one important thing to highlight is you could theoretically in your program have a lot of different numbers flowing in here. We just know right now that we have, some color flowing in, but because the matching is done on integers, it can be a good idea to define a base case as well. So this is sort of general principle when you write F# code, that it's good to define a base case in these match statements. So in case you add one of the columns here, or like if you add another color to your set of colors that you've defined, potentially you would miss your match statements. So having this base case at the end, just returning, for example, unknown, is a good way to structure safe code. So we have that, and this would give us now a string corresponding to the color that we have in our variable. And you can see that we used myCol here, which we define based on the integer. So what we're doing is we create an integer, we convert that to a color, and then we create a string with the color name, and then finally we can print that if we want. So we just do a print statement, and then we would write like the corresponding color is, and then we would do a string, and in here, we could do my string. Okay, like so. So if we save this script, we should be able to execute it. And if we look up here, how we define the color, you can see that the number 1 that we defined here corresponds to green. And so we would expect that we catch this statement here and actually print green in our terminal. So if we let this finish, we can see that the corresponding color is green. So everything works, and that's how you use enumerations in F#.